drawing method, right? Here is topic 2.0, and under this topic I get 2.1 general theories, right? We need to know that some facts are called how many bonds form between this atom or that atom, and what electrons we need to consider, right? Like this. Then first one is we must consider about what all valence electrons. Need to consider about all valence electrons. This one always we need to consider, right? Then another one, what usually they got the octane, right? Usually they got the octane. Why I am here with the usually? When we draw the structure of beryllium chloride, this beryllium not get the octane, right? It's only have what, 1 2 3 4 4 electrons, right? Therefore it's not occupied the octane, but it's the stable molecule. Then third one is sometimes these atoms can have what, double bonds and triple bonds, double and triple bonds, right? Then which atoms form double and triple bonds? What are the atoms? Carbon, nitrogen, oxygen, phosphorus, sulfur, and halide with oxygens. Halide with oxygen, I put this X for halide and oxygen, like this, these for these types, right? Then these are the basic theory. Another one is we need to know or draw correct skeleton for molecule, right? These are the what basic theories for drawing of Lewis structure. Then I'm going to describe the method by using example number 1. My example is what, nitrate ion. I'm going to another page, new page, right? This one, nitrate, sorry, nitrite, example 1. Right here, first we need to know that the correct skeleton. When we go choose the central atom, here central atom, central atom is the most electropositive atom. Most electropositive atom or least electronegative one, right? Between these three atoms, one nitrogen, two oxygens, basically two elements. Nitrogen is less electronegative than oxygen, therefore nitrogen is most electropositive one. Then this nitrogen, what happens? Combine with two oxygen atoms by using two bonds, two single bonds. This one is then what, sigma bonds, and also this one sigma bonds. Basically always the skeleton formed by using sigma bonds, and the bond strength increased with the 5 bonds or double bonds or triple bonds, right? Now we know here two sigma bonds here, right? Then what we do, count the second step. Here step 1, I put the charge, drawing the correct skeleton. Then what, count the charge, count the valence shell electrons. valence electrons. Right here, NO2 minus for nitrogen is 5, and for oxygen 6 by 2, and for minus charge 1 electron. Therefore 5 plus 6 by 2, 12 plus 1 is 18 electrons. Then third step, uh, count the bond electrons here and subtract those from total valence electrons. Or here you can see the valence electrons or valence electron pairs. Pairs come from this one divided by 2 and 9, right? For easiest method, I use the electron pairs. Now you can see here 2 electron sigma bonds and 2 electron pairs. Now 9 subtract 2 equals 7, right? Then what I do here, fourth step, what I do, put electrons to the skeleton, right? Put electrons to skeleton by giving the octane to each atom. Here also we have priority. First what? I put the stomach first for most electronegative one. If you don't know what means electronegativity, go to the link at the description and learn about that. We already made the video for electronegativity, right? Then forward second for least electronegativity ones, right? Then here we know what my structure is now: nitrogen, oxygen, oxygen. Oxygen is most electronegative than nitrogen. Now I have 7 electron pairs. Then what I do, for each oxygen now I have 1 sigma bond. That means 2 electrons. Forget the octane, it needs another 6 electrons or 3 electron pairs. I put these 3. Then you can subtract these 3 and remaining 4. I do same for another oxygen atom. Then subtract 1 here. The remaining electron pair I give the nitrogen. Now you need to do what? Now step 5, what you need to do, make double and single bond, right? Why? Reason is here, no, not gain the octane. So it needs more electrons to get the octane. Therefore, what we need to do, make double and triple bonds and fulfill the octane for central atom. Here you can see 1, 2, 3, 4, 5, 6 electrons, and nitrogen needs another 2 electrons to get octane. Therefore, I give 2 electrons from here. And now you can see the structure like this, like this. Then final step is what? Sixth step I will drawing here, put charges. How? By calculating what? Valence shell electron pairs or electrons. It not maybe it pairs or electrons, right? Here how many electrons in the oxygen combine with one bond of one bond between nitrogen. Here how many? 1, 2, 3, 4, 5, 6, 7 electrons. Therefore it can hold the 6 electrons for valence. Therefore I put -1 charge. For nitrogen 1, 2, 3, 4, 5, it's okay. Oxygen 1, 2, 3, 4, 5, 6, it's okay. Then my final structure like this. right? I erase these 2 marks, and this is my final structure for nitrite time, right? It's easy, and it's easy if you follow the correct method. It's maybe difficult if you uh, not follow the correct steps, right? Then another example, I go to the thiosulfate type. Example number 2, thiosulfate type. Here you can see our first step is drawing of skeleton, and what happened in here, uh, sulfur is the central atom. How I get sulfur for central atom? In the periodic table, oxygen, sulfur, then, right? Like this. Then group 16, A. Then what happened when it goes down to same group? Electronegativity decreases. Therefore, oxygen has highest electronegativity than sulfur. Then most electropositive one, sulfur. Then it's the central atom, and it's combined with one sulfur atom and 3 oxygen atoms, like this, right? Then you can see there are 4 sigma bonds. 4 sigma bonds. I write this one is here, like this. Then what you need to what's another step? Another step is calculate the valence electrons here. 2 sulfur atoms, 6 by 2, 12. Another 3 oxygen, 6 by 3, 18, plus 2 for negative charge, means 32 electrons, and I divide this by 2, and 16 electron pairs, right? Then what I do, subtract 4 bonds pairs and remaining 12. These 12 I give by the electronegativity order. Then oxygen has highest electronegativity. Therefore, first I give electrons to oxygen. In here, each oxygen and sulfur atom already have 2 electrons, and it needs another 6 electrons or 3 electron pairs. I put, right, these 3, can subtract the equal 9, another 3, can subtract another 3, 6, and another 3 here, right, 3, remaining 3. That's remaining 3 electrons I give finally, but for sulfur atom. Then you can calculate the octane here, right? What happened in octane? All electrons get the octane. Sorry, all atoms get the octane, including central atom, right? It's okay. Then what need to you do? Calculate the valence electrons and put the charges. Here each oxygen and sulfur atom also have how many? 1, 2, 3, 4, 5, 6, 7 electrons. 7 electrons, therefore negative 1 charge. Here also 7 electrons, negative 1 charge. Here also 7 electrons, negative 1 charge. Here 7 electrons means negative 1 charge, and here sulfur middle central atom only 1, 2, 3, 4, that means 2 plus, need to get 6 electrons. Now I write this like this: sulfur, oxygen, and oxygen here negative charge, here negative charge, here negative. Oh, here sulfur also contain negative charge. Now what I do, here 2 plus. There are massive charge distribution in here, right? Massive charge distribution. Therefore, I minimize these charges by making double and single bonds. First of all, you need to, when you making the double and single bonds, you need to choose least electronegative one to donate electrons for bond pair. Therefore, sulfur is least electronegative one. This one convert bond pair. Then what happened here, negative charge and one positive charge cancel out. Again I get another oxygen atoms, any oxygen atoms between these three, and form double bond. Then finally structure I can get like this. Here double bond, oxygen atom hold negative charge, then double bond, then single bond and negative charge like this. This is the final structure for thiosulfate. And please put electrons clearly. If you put electrons like this one may be considered one electron, therefore like this, right? Then I move to another example, example number 3.